Hi guys, today we are going to take a look at our first conic section, which is a parabola. Okay, and I know you're somewhat familiar with parabolas from graphing equations, but today we're going to look at them a little bit differently. So make sure you're paying attention and not just thinking that you know what these are. All right, so this is an example of a parabola right here. The definition of a parabola is, if you look over here in the box, it's the collection of all points in the plane that are the same distance from two things. One is a fixed point called the focus. This is the focus. And another is a fixed line, which is called the directrix. And that's what this down here is. So this is a line. Okay, so we've got a line and we've got a point. And then this parabola is made up of all the points, so these are all just a whole bunch of points, that are the exact same distance from these two objects. So like this point right here is the same distance from the focus as it is from the vertex, or from the directrix. Okay, this point way out here is the same distance from the focus as it would be from the directrix. An obvious point to notice is this point right here. The bottom of your parabola, which is the vertex, would be the same distance, so this is like up 1 unit to the focus, and it's down 1 unit to get to the directrix. So that point right there is the same distance from the focus and the directrix. That distance, I'm actually going to label with a variable. I'm going to call it P, and you'll see why here in a second. When we graph a parabola, we're going to want to graph the vertex, we're going to graph the focus, we're going to graph this directrix down here, and we're going to graph two other things, this point and this point. And these are called lattice points. And besides the vertex, these are the only 2 points that are actually on the parabola that we're going to graph. But once we have our vertex and once we have these 2 lattice points, then we can just get the shape of our parabola. Okay? So that's kind of the definition of a parabola. Now, if you look down here, you're going to see this is the equation of a vertical parabola. So, vertical. If the x is squared, so notice when you're looking at a parabola, you've got a squared term and then a non-squared term. That's just a plain y. Okay, the squared term. If the squared term is your x, it is a vertical parabola. So x squared equals 4py. Okay, this is the standard equation for a parabola. And again, that p, that's what I drew up here. That number right there is the distance between the vertex and the focus. This parabola right here has a vertex at the origin. Okay, so our origin, so the point 0, 0, would be the vertex of this parabola. And that's the first thing we would graph. So we would go to 0, 0, we would put a point right there, and that's our vertex. The next thing we would graph would be our focus, because that focus is p units above our vertex. So that's what that p is in the equation. So the first thing you do is you're going to see a number right here. We're going to rewrite this number as 4 times something, because that something, that p, is how we're going to find the other parts of our parabola. Okay, so you need to know 2 things, literally. You need to know where the vertex is, in this case it's 0, 0, and then you need to know what that p value is, because that p value tells you everything else. Okay, your focus is going to be p units from the vertex. Okay, so once I know what that number is, I'm going to go up that amount, and that's p. Let me jump down here to the lattice points. The lattice points, the points here to the left and to the right, these 2 points on the parabola, are 2p units from the focus. Okay, so I'm going to go up p, and then I'm going to double that number, whatever that number is. I'm going to double it, and that's how much I'm going to go left and right to find my lattice points. your directrix would be negative p units from the vertex. Okay, so if I went up 3, I'm going to go down 3. And that's where I'm going to draw my directrix. Okay, so let me go ahead and just do an example of a problem like this. So look at number 1. Look at the first example on number 1. So here is my parabola. So x squared equals 8y. Because the x is squared, this is a vertical parabola. The first thing I do is, well, I could do a couple of things first. First thing I may notice is that because there's no numbers attached to the x and the y, that this vertex is at the origin. Okay, so I'm going to go to the origin. That's my vertex. 0, 0. That's my vertex. But another thing that you could do first is take the number that's in front of the y and split it into two numbers. 4 times 2. That 4 is the 4 that's up in the equation right here. Okay, think of this as a formula. That 4 is part of the formula. So you have to rewrite the 8 as 4 times something. In this case, the number 8 would be 4 times 2, so that's how we write it, 4 times 2. That 2 is our p value. So when I go to graph this, I'm going to go to my vertex, and I'm going to go up 2. That's my focus. I'm now going to double that number, and that's how much I'm going to go left and right to find my lattice points. So if I went up 2, I'm going to double that, and that'd be 4. So I'm going to go right 4, 1, 2, 3, 4. I'm going to go left 4, 1, 2, 3, 4. And these are the points on my parabola. This parabola goes up this way and goes this way. And that's my parabola. So the focus would be this point right here, the point 0, 2, 0, 2. And then the only thing I haven't graphed would be the directrix. Well, again, if my focus was 2 above the vertex, my directrix is going to be 2 below. So I'm going to go down 2, and then your directrix is a line. It is a horizontal line that goes through the number -2. So I'm going to draw that line. I'll draw it as a dotted line. If you draw it as a solid line, that's okay. But I'm going to draw it as a dotted line just to show that it's actually not part of my graph. It's just a tool that I'm using for my graph. But that horizontal line, y equals -2, is my directrix. Okay? Now, parabolas don't have to be centered at the origin. Okay? So this would be the example of an equation where the vertex is not centered at the origin. Okay? So if your x and your y have numbers being added or subtracted to them, that is going to shift where the vertex is. So x minus h squared equals 4p y minus k. So the only thing we've changed is we've taken x minus a number and we've taken y minus a number. Those two numbers, h and k, that's going to be where your vertex is. So that'll be the first thing we do. We're going to go to those two numbers. We're going to put a point. That's our vertex. And then everything else is the exact same. Once I know what p is, I'm going to go up that amount. To find my focus, I'm going to double that, go to the left, go to the right. Those are my lattice points. And then I'm going to go in the opposite direction of P to find my directrix. Okay? Notice that the minus signs, the subtraction, is part of the formula. So if you see a -3, then H is actually a +3. Okay? The minus is part of the formula. So when you go to find your h and k, they're going to be kind of the opposite of the two numbers that you're going to see in there. Okay, so let's look at an example of a parabola where the vertex is not at the origin. Okay, so here's my equation. Again, x is being squared, so this is a vertical parabola. First thing I'm going to do is I'm going to find my vertex. My vertex is at -2, -1. -2, -1. So -2, -1. That's my vertex. Then I'm going to take the number that's out in front of the y, and I'm going to split it into 4 times something. Well, this was a -4. So 4 times -1. That's the p value. Okay, so p is -1, which means this parabola is going to open down. Okay, if the p is negative, when I go to find my focus, I'm going to go down 1, where on the other one it was a positive p, so I went up 2. Okay, but this one is down 1. That's my focus. If I went down 1, I'm now going to double that number, so that'd be 2, and that's how much I'm going to go left and right from the focus. And these are my 3 points that are on my parabola. So this parabola is going to go this way and this way. If I went down 1, and that's where I found my focus, I'm going to go up 1, and that is where my directrix would be. So this is your directrix. Okay, this one I made it as a solid line. Okay, doesn't matter. Solid line, dotted line, this is your directrix. Okay, so the directrix is sitting right on the x-axis. So the directrix would be the line y equals 0. My focus is this point right here. Well, what is that point? It's -2, -2. So there's my focus, -2, -2. All right, now on the back page of the notes, you're going to see that for these parabolas, we can also have parabolas that go in a horizontal direction. So earlier in the year, we were graphing parabolas, but they always went up or down because we were dealing with functions. Well, this is obviously not a function. It would fail a vertical line test, but it is an equation. So this is the equation of a parabola that's going in a horizontal direction. Notice that for the horizontal parabola, it's the y that's being squared. So if you see y squared, the first thing you want to think of is this parabola is going to go in a horizontal direction. Okay, so we are still going to graph our vertex first. And then when we go to find the focus, we're going to move horizontally to find that focus. Then we're going to go up and down to find our lattice point. So everything's just going to be kind of shifted as far as our directions go. Okay, your focus is still going to be 2 units, or p, your focus is still going to be p units, whatever p is, from the vertex. Okay, it's just that we're going to be going left or right to find that instead of up or down. Again, if p is positive, we're going to go to the right because that's a positive direction. And if p happens to be negative, then we're going to go to the left, and the whole parabola is going to be shifted to the left. Okay? For this, our directrix will be a vertical line. Okay? And it's going to be the opposite of p. So if I draw that, a vertical line is always x equals. And then whatever p is, it's going to be the opposite of p. That's how we're going to get there. Okay, your lattice points are still going to be 2p units from the focus, but again, in this case, it's going to be 2p units above and below. Again, you don't necessarily have to have a parabola that has a vertex at the origin. This would be an example of one that does not. And again, you're going to see numbers being added or subtracted to the y value. Now, here is the common mistake. Please pay attention. Okay? Notice the vertex is at hk. The h is still the number that's connected to the x variable. The k is still the number that's connected to the y variable. It is very common for people to just grab this number first and this number first and think of that as your x and that's your y when you go to graph your vertex. Okay, you've got to make sure that the x direction, so if I'm going to the right, whatever, that's the number that's connected to the x variable. And the k, the up and down location of the vertex, is the number that's located to the y variable. Okay, so it's a really common mistake, so please try to pay attention to that. All right, so let's graph this parabola right here. Now, I've got y squared, so as soon as I see y squared, I know this is going to be a horizontal parabola. Now, I don't necessarily know it's going to be horizontal this way. It could be horizontal going the other way, but that's what I'm thinking in my head this whole time. Now, you'll notice this is not in standard form. This is not written like either one of these two formulas. We're going to have to get it into standard form by completing the square. We want this. We want y minus k squared. We want something squared. We want a nice perfect square right here. So we're just going to create that. Okay, so let's take y squared. We're going to put plus 4y, and then we're going to leave a blank. That's where we're going to complete the square. Anything that is not a y in this case, we're going to move to the other side. We're going to move the 16x to the other side. We're going to move the minus 44 to the other side. That'll become plus 44. And remember, when we complete the square over here, anything you add to the left, we're going to have to add that same thing to the right. Okay? So, this magic number is going to be half of that, so 2, squared. So that's going to be a 4. So that's what goes in that little blank, and that's what's going to go in this little blank over here. Okay, so I've balanced out my equation. I came up with the number that I wanted that'll make this a perfect square, but then I balanced it out over here. Okay, so let's simplify and see what we've got. This now factors into y plus 2 squared. This simplifies into 16x plus 48. We are almost where we want. Okay, this is what I want it to look like. I've got the y plus 2 squared, so I've got a perfect square on the left. Over here, I need to have like an x minus some number in parentheses. There should be nothing in front of the x. Anything in front of the x should be factored out here. So let's take a look at what we've got. So this is fine. Y plus 2 squared. And then over here, I need to factor this 16 away from the x. So we're going to factor the 16 out. That number needs to factor from both of these, and in this case it does. 16 goes into 48 3 times. Now we're in the right form. I can tell, well, the y is being squared, so I can tell this is a horizontal parabola. I can tell where my vertex is. It's going to be, so remember, there's a minus sign that's part of the formula, so it's the opposite of these two. But the vertex is at -3, -2. You got to look at the number with the x first. So -3, -2. That's our vertex. So that'll be the first thing we graph over here. -3, -2. And now I need to start moving. I need to find my focus, my lattice points, all that stuff. That's going to come from this. We always rewrite this number as 4 times something. Always. Doesn't matter what that number is. It's always 4 times something. In this case, it's 4 times 4. That's our p-value. So that's how we're going to move to find our focus. Remember, this is a horizontal, so we're going to move moving to the right. So we're going to move 1, 2, 3, 4. That's where our focus is. If I move 4 to get to my focus, we're now going to double that, and that's how much we're going to go up and down to find our lattice points. From the focus. Don't go back here. From the focus, we're going to go up 1, 2, 3, 4, 5, 6, 7, 8. We're going to go down 1, 2, 3, 4, 5, 6, 7, 8. And this is going to be a really big, wide parabola. Looks something like that. Okay, so there's our vertex. Here's our focus. Now, where is our focus? What is that actual point? Well, that is the point +1, -2. So 1, -2. Our directrix, if I moved 4 to the right to find the focus, the directrix will be 4 to the left. 1, 2, 3, 4. And then it is a vertical line that goes through that point that I just made. And that would be the vertical line x equals, well, it's going through -7. So x equals -7. And that's what you need to be able to do. Draw and tell me that information. All right, we're going to try one more of these. Find the vertex focus directrix of the parabola, graph the equation. All right, so we're going to graph the equation first, and then we're going to get this information from that graph. So again, this is not in the standard form that I want. Okay, so I need to get that. I notice that the y is squared, so that's what's going to stay on the left-hand side. I also know this is a horizontal parabola because the y is being squared. But I'm going to have to get this in the right form. So I'm going to have to do some completing the square here. So I'm going to put plus 4y. So I'm going to leave the y squared, and I'm going to leave his buddy, the y that's not squared. And then I'm going to leave a blank, and that's where we're going to complete the square. Then I'm going to take the minus 4x, and I'm going to move him to the other side to get him out of the way. He needs to be over here. And then see if you, I'm going to pause this. You can pause the video for a second. See if you can finish this and get it into the correct form. All right, this is the correct standard form that we want. Okay, I added a 4 here. I had to add a 4 over here. This is now a perfect square. And then over here, I factored out the 4 that was in front of the x, and I had to factor it out from both of these terms. So I factored out that common 4, and this is what I got. So what do I know? I know the vertex is at -1, -2. -1, -2. So let's graph that. -1, -2. There's my vertex. I'm going to take the number 4, and I'm going to rewrite it as 4 times something. Okay? You don't get to choose how to factor that. You don't get to say, well, oh, 4 is 2 times 2. No, it's 4 times and then whatever. In this case, 4 times 1. That's P. So since this is a horizontal, I'm going to move 1 to the right. That's my focus. From the focus, I'm going to double that movement and go up 2 and down 2. So that's my parabola. The focus is at 0, -2, so 0, -2. And then my directrix. If I went 1 to the right, I'm going to go 1 to the left. Do not stop. It's not a point. It's the line, the vertical line that goes through that point. So there's my vertical line. That vertical line is going through -2, so x equals -2 is the equation of my directrix.